Way up there, moving faster than you can imagine. There are these invisible rivers of air, and they pretty much run the show down here. They control our weather, they give our airplanes a serious boost, and, well, now they're starting to act a little strange. So today, we're going to make the invisible visible. We're diving into the jet stream. Okay, let's start with something you might have actually noticed. Ever wondered why your flight from New York to London seems to zip by, but the trip back, it just drags on? It's not your imagination, I promise. The plane is literally catching a ride on this giant, invisible highway in the sky. And that highway is what we're talking about today.
All right, so here's our game plan. First up, what even is the jet stream? Then, we'll get into the two key ingredients that cook it up. After that, we'll see how it pulls the strings on our weather, how it affects our lives in ways you might not expect, and finally, we'll ask a big question. Is it heading for a more extreme future? Let's get into it.
Okay, first things first. What exactly are we talking about here? The best way to get your head around the jet stream is to just picture a river. A huge, fast-flowing river, but it's made of air. So the official definition is pretty straightforward. It's these narrow bands of really strong wind, and they're way up there, around 30,000 feet, right where you'd be flying on a long-haul flight. The key thing to remember? They always flow from west to east, wrapping all the way around the planet.
And that river of air analogy? It's honestly perfect, because just like a real river, it's not all moving at the same speed. The fastest part is right smack in the middle. That's the jet core. And then, as you get towards the banks of the river, the wind slows down.
And when I say fast, I mean fast. We're not talking about a stiff breeze here. The fastest wind ever recorded in the jet stream clocked in at a jaw-dropping 650 kilometers per hour. To put that in perspective, that is almost as fast as the airplane itself is trying to fly. Just imagine that power. Now, here's a little twist. It's not just one single river. In both the northern and southern hemispheres, there are actually two main ones. You've got the polar jet, that's the wild, wavy one that really messes with the weather in North America and Europe, and then there's the subtropical jet. It's a bit higher up, a little closer to the equator, and it tends to be, well, a bit more well-behaved. All right, so we know what it is, but the big question is, why? Why does the atmosphere even create these super focused wind tunnels? Well, it turns out the recipe is surprisingly simple. You only need two key ingredients.
Ingredient number one, the sun. It just doesn't heat the Earth evenly. The equator gets absolutely blasted with direct sunlight, while the poles just get these weak, glancing rays. So you have this massive temperature difference, right? And the atmosphere hates that. It wants to balance things out by moving all that hot air from the equator up to the poles. Simple enough. But that moving air runs into ingredient number two. Our planet is spinning.
And this is where the magic happens. It's called the Coriolis effect. Think of it like this. If you're standing on the equator, you're whipping around to the east at over 1,600 kilometers an hour. If you're at the North Pole, you're basically just spinning in a circle. So when that air from the equator starts moving north, it doesn't lose that incredible eastward speed. From the perspective of the slower moving ground below, it looks like it's being pushed to the east. And that push, that's what creates the jet stream's powerful west to east flow.
Okay, so we've got this massive river of air way up in the sky. So what? How does that affect us down here? Well, it turns out this thing is basically the puppet master of our weather, pulling all the strings for the forecasts you see every day.
Now, a key thing to get is that this river doesn't just flow in a nice, neat circle around the globe. No way. It wiggles and wobbles all over the place. It forms these massive planet-sized waves called Rossby waves. And the shape of these waves? That is everything.
It works like this. When the jet stream takes a big dip south, we call that a trough. That dip basically forces the air below it to spin and rise up, and bam, you get a low-pressure system. That means clouds, rain, storms, the whole shebang. On the flip side, when it bulges northward, that's a ridge. That pushes air down, creating high pressure, and that means clear skies and calm weather. So the jet stream literally creates our weather systems, and then it acts like a giant conveyor belt, steering them around the world.
So let's bring this right down to earth. Why should you care about this invisible river? Well, its impact on our daily lives is actually pretty huge, in some really surprising ways.
We feel its effects all the time. For starters, aviation. Remember that faster flight to London? Pilots heading east will literally find that river of air and ride it like a surfer on a wave. It gives them a huge tailwind, saving tons of fuel and cutting hours off the flight time. Then there's the temperature outside your door. The jet stream acts as a sharp boundary. If it's north of you, you're in the warm air. If it dips south, get your coat, because the cold polar air is coming for you. And here's a fun one for any astronomers out there. When the jet stream is really turbulent above you, it makes the stars twinkle like crazy and blurs the view through a telescope. They call it bad seeing.
Okay, this brings us to the final piece of the puzzle, and it's a big one. What happens to this whole system as our planet warms up? There's growing evidence that our weather's reliable puppet master might be getting a lot less predictable.
So here's the thinking. The engine that drives the jet stream is that huge temperature difference between the icy Arctic and the hot tropics. But here's the thing. The Arctic is warming up way faster than anywhere else. That shrinks the temperature difference, which takes some of the fuel out of the jet stream's engine. It gets weaker. And a weaker jet stream becomes a wavier jet stream, one that's more likely to get stuck in these big loopy patterns for days or even weeks. And when a weather pattern gets stuck, that's when things get extreme. You end up with relentless heat waves that just won't quit, like we've seen in Europe. Or you get a deep, wavy dip that gets locked in place and brings an insane polar vortex cold snap down into the U.S. Midwest. Or that terrifying heat dome in the Pacific Northwest. More and more, scientists are pointing the finger at a wobblier, more unpredictable jet stream as a key player in these kinds of prolonged extreme events.
So it leaves us with this really critical question. The jet stream has always shaped our world, always been this powerful dynamic force. But as we keep changing the basic energy balance of our planet, are we breaking our weather's puppet master? Is this incredible river of air starting to lose control? That's definitely something to think about.